Assalamualaikum and hi. My name is Adibah Syazwani binti Azhari and our group will represent about water hyacinth. Water hyacinth, or also known as Iconium crassipes, is a perennial aquatic herbaceous plant that belongs to the pickerel weed family. It is also a native to tropical America. It has been classified as one of the worst aquatic weeds in the world. However, the plant has spread to the many parts of the world due to its popularity as an ornamental plant for ponds. The leaf of water hyacinth contains 11 to 50% of proteins that provide foods for various species of animals, including manatees and species of turtles. Now, let me tell you why we shoot this species. Water hyacinth is a good method to study the effect of crude oil because the species is highly effective in removing excess nutrients, heavy metals, toxic metals, herbicides, mineral, and and organic chemicals from polluted water. Therefore, a laboratory studies of the water hyacinth have demonstrated the potential use of this species in removing petroleum from contaminated environment. Hence, the objective of this study to evaluate the effect of Uruku crude oil on the survival of the and growth of water hyacinths to answer two main questions, which is: first, does the morphology and biomass production of the species respond to different doses of oil? Second, does increasing time of exposure affect biomass production and mortality of the plants? That's all for me. Thank you.
Effect. Although exposure water hyacinth to Uruku crude oil had a limited impact on the growth parameters, the interaction of oil dose and time of exposure increased the oil's effect, causing great mortality in the plants. The impact of 20 days of exposure to oil led to a reduction in the relative growth rate of leaves in all oil treatments and reductions in the ratio of live or dead biomass due to the increase in dead biomass. Dose and oil type are two of the most important variables that determine the degree of oil damage in plants. Since Uruku oil is light and therefore more damaging to the metabolism of plants, this may explain the increased mortality observed, especially at the higher oil doses. The oil doses did not affect the maximum length of the roots of live plants and its biomass in the 20 days of exposure in the present study. However, studying water hyacinth in a period of 35 days, comparing the initial and final length of roots of all plants material, live and dead, show that Uruku oil causes a significant reduction in the length of the roots, which indicates that the parameter and may be affected with time exposure.
The sample were collected from stem of the species. Second is it was conducted in a greenhouse for 15 days with natural sunlight and temperature. The third is the sample unit consists of 300 individual plants in vessel distributed in a completely randomized factory design with 10 replicates. Next is young healthy individual with 3 leaves were collected in the field. The plant was placed in vessel with 2 wine of water for 13 days. Next is a crude oil was placed on the surface of water. At day 1, day 5, day 10, day 15 and 20, the plant were measured and harvested for biomass. pH of water also measured. Lastly is area biomass was harvested and separate into dead and leaf component and dry until 65 degrees Celsius. The total biomass was calculated.
Based on the results, the following parameters were tested with an interaction between time exposure and oil dose. Firstly, it affects the number of leaves. The day 1 of treatment, the plant shows an increased number of leaves. Until it reached 20 days, the test parameters could not be analyzed because of dead plants were excluded. Second, the length of roots is not affected by dose exposure. Next, the total of biomass. Live biomass was trended to decrease, but the accumulation of dead biomass increased significantly until 20 days of exposure. For aerial biomass, after 20 days, there was an ascendancy of a reduction in aerial biomass. Also, for the ratio of live and dead biomass between 5 to 20 days, there was a significant decrease and reduction in the treatments. Next is the ratio of root and shoot biomass. It showed a significantly increase after 20 days. Lastly, for the pH, the increasing was observed between 5 and 20 days. At first, it was neutral until it turns to acid after oil addition. For the conclusion, dose and time of exposure are two of the most important factors controlling the effects of uropetroleum hydrocarbons on ecrasids. While relatively low doses of oil may cause a reduction in the number of leaves and plant biomass, high doses can even cause death of the plants. The lower dose of urucum oil tested, 3 ml, did not cause significant alteration in morphology and biomass of the plants. Moderate oil doses, 12.5 and 25 ml, caused an increase in dead biomass and a decrease in the ratio of the live and dead biomass, and also the number of leaves. When exposed to high doses, 75 and 150 ml, the decline in biomass and increase in plant mortality were intensified. Considering that the higher dose tested is well below the values, we may conclude that Echinacea crassids is highly affected by urucum oil. The time of exposure and oil dose had a synergistic effect characterized by the intensification of the alterations in morphology, decrease in biomass production, and increase in dead biomass from the first 5 days of exposure up to the end of the experiment. Thank you.